Moving on to number 11. So again, we want to see, does the series converge? Does it converge absolutely, conditionally, or does it diverge? So let's go ahead and play with that. So A, we're looking sum n equals 0 to infinity of minus 1 to the n times n over 4n plus 3 to the n. And so now we take a limit, or not a limit, not yet. What do we need to do? This looks like a prime candidate for a power, what is it, root test, a root test. So we use the root test. Okay, so we want to use the root test this time around because everything's got this power of n on it. So limit n goes to infinity of absolute value. I don't need the minus 1 to the n because I'm taking absolute value. 4n plus 3 to the n to the 1 over n. Those cancel. And I get n over 4n plus 3, or 1/4. That's less than 1. So the series converges absolutely. There we go. Series converges absolutely. You'll love to see it. Part B. What's the sum this time? This one looks like it would be a doozy. Minus 1 to the n, minus 1, 2n squared over n squared plus 1 to the power n. So first thing I'm going to note is I can tell these terms don't even go to 0, so it automatically diverges. So I'm going to write that in blue. Automatically diverges just by the divergence test. By divergence test. But, in fact, or let's pretend like we didn't notice that. So let's look at this and say, okay, I don't know if this should converge or diverge, so let's use the root test. Use root test. So I look at the lim, n goes to infinity, 2n squared over n squared plus 1 to the n, like that, to the 1 over n. That's the limit n goes to infinity of 2n squared over n squared plus 1 equals 2. That's strictly bigger than 1. And the root test actually knows what to do here. Since it's bigger than 1, the series diverges. So usually if you're vigilant, you don't actually have the use the root test to say something diverges. But just in case you forget, if you see the n and you go for it, you're not going to do it incorrectly. You're just going to make a little bit more work for yourself. But it's okay to do some more work for yourself if you get the right answer. And so that's our answer here. Again, pretending we didn't know. We didn't see divergence. Okay, just to let you know, this will still work. And then let me go to the next page for C. (11C). Now we've got the sum from n equals 2 to infinity of 2 times 1 plus 1 over n to the n squared. So here's another one. N goes to infinity, 1 plus 1 over n to the n squared. And I go, I don't know what that goes to. But actually, it is pretty quick to see this would diverge, because that thing in the power there is going to 1. Well, if I got rid of this, the thing on the inside would be going to 1. The n squared is going to keep it 1, so this diverges. But again, let's pretend like we didn't know that. Okay. But let me make a note in blue in case somebody comes back and reads this. Could use divergence test one more time. But there's an important fact that I want to bring up here. So I look at the limit as n goes to infinity of 2, 1 plus 1 over n to the n squared to the 1 over n. And I get the limit n goes to infinity, 2 to the 1 over n, 1 plus 1 over n to the n now, because I had n squared. So the 2 goes to 1. That's no issue. But what happens here? I have 1 plus 1 over n to the power n. And you might have forgotten, but this is equal to e. Which is bigger than 1. So the series diverges. Again, the root test can give you negatives just like the ratio test can. So if you take a root of a limit, get bigger than 1, then your series automatically diverges. And that's how you do number 11.